Hey class, possibly your last video, we'll see, hopefully it is. Just another example of doing a projectile that is from an elevated height. I'm trying to figure out exactly how far or how high these kind of things go. So this one's actually not on your worksheet, so if you want to try this one out, look at it, draw it, pause it, try to answer yourself, and then see what you do. So I've got the question here. Well, I got to do this first. And I think I got the question ready to go here. Yeah, there it is. Okay. So I'm going to kind of read it first, and then I'm going to draw it, and then you guys can also kind of draw it. So it says, in the diagram below, a shell, so basically like a shell that's launched from some kind of rocket or from a cannon, has an initial speed of 4.4 times 10 to the 2, okay, also known as 440. So you see this, 4.4 times 10 to the 2. Move the decimal 2 spots, you get 440. Okay? So a little reminder on scientific notation. We basically have 440. Velocity equals 440. 30-degree angle from the deck of a ship. If the ship is at rest, so it's just sitting there, there's no extra velocity from the ship, and it's launched 20 meters above sea level, how far will the shell travel horizontally, the x direction, from the original position? Okay? There's no friction, don't worry about that. All right, so let's draw this out. So basically, we have, I'm going to have velocity equals 440 at 30 degrees. So we have this water, we have this ship, it is 20 meters above, okay, and it is shot at that 440, 30 degrees. Okay, we want to find this over here eventually. Okay, want to figure out this distance in the x direction. All right, let's do our first thing. Vx, Vy, Vx, Vy. We get Vx of 381 and a Vy of 220. All right, again, I'm going to cut it right there in half. All right, I want to know what the time is to the halfway mark, and then also how extra high this went there. All right. So I'm going to use this formula again. I use this formula a lot to find my time right here. Because I have my acceleration, I have my VI, like my initial velocity in the y direction. So time to this part right here, we're going to go with negative 9.8 equals 0 minus 220 over time. Switch them. Time equals negative 220, negative 9.8. We have a long time here, a lot. It gives us a time of 22.5 seconds. 22.5 seconds. That's a long time that is in the air. But again, you're shooting at 440 meters per second. This thing's going to travel pretty far. So, all right, we got our first time there. I'm going to erase this. Now I want to know the distance. I want to know how much higher in the y direction. Distance in the y direction. I want to know how much higher it went, because that's going to, I need that to figure out exactly how much more time, how much extra time it's going to take to land. Because the time here is not the same time here. I'm elevated here, so there's extra time that it's going to be in the air. So, how do I figure that out? Well, now that I have the time, I have my two V's, like for in my y direction. Again, I like using this formula to figure out the distance up. So distance, my initial velocity in my y direction was 220. At the top of this, my Vy is 0, so that's going to put plus 0. Divided by 2, multiplied by my time, 22.5. Okay, when you do this, you get a very, very big distance. You get this thing traveled just upwards in the y direction, 2,000. 475 meters. That is a lot. That is how high. It went basically 2.5 kilometers in the air, high. Okay? So that's far. So that is the distance that it went up. We need to know the total distance that it is in the air now. So if I add my extra 20 meters, which is kind of negligible at this point, but we still have to add it, the distance at the very top, when it gets this high, it is at a distance of 2,495. Okay, just that, plus it was on the ship at 20 meters. So add them together, there's my distance at the top. Cool, all right. Now let's figure out the second half of this question. Now that we know this, we can figure out the total time and then we can figure out the total distance in the x direction. So we just need the time now. We are this high up. Okay, we need to know how much it's going to take to land. All right, again, our Vy at the top is 0. We have this new distance, so let's actually figure this out. Okay, I'm going to use this one right here. Okay, this is the formula that I like to use. This is the formula that we used at horizontal. I like using this formula just to kind of get it. You can do it other ways, but it's a little trickier and harder. So the distance, we have the distance that we started from at the top now. The VI initial velocity is 0, and so it just turns into this little part of the formula. So our distance equals, and actually I won't do that, I'll put in this big number, 2495 equals 0 multiplied by time, I don't know, plus 1/2 9.8 t squared. That cancels out. I'm going to divide the 4.9 now. When I do that, I get 509. Okay, so basically I turn this into 4.9, divide this by 4.9, and I get 509 equals t squared, so square root, time equals 22.6. 22.6, again, and that kind of makes sense. You think it's probably close to the same time because, well, like, it's only an extra 20 meters from 2,495, and the distance to here is 2,475. So we're talking 20 meters doesn't make a big difference. It made 0.1 of a second difference. All right, time to here is 22.5. Time to here is 22.6. So total time equals 45.1. Just add those two together. 45.1 is the total time that's in the air. Now we have total time. We can use our Vx to figure out the total distance in this way. So distance equals my time, 45.1 multiplied by 381. This cannon, this shell, really flew 17,183 meters. That is how far it flew in the x direction. So at 17, just over 17 kilometers. Okay. I actually looked up basically the average velocity of a seaboard cannon, and it's about that. It's about 440 meters per second. So these things are traveling about 17 kilometers if they want, which is pretty impressive, honestly. Man, third time today. This light does not like me standing right here. Supposedly there's a dead spot. Okay, so hopefully this made a little sense. Again, it's a lot of kind of understanding the Vx and the Vi, breaking it apart and making sure you see these little parts. Hopefully it's starting to make sense though. If not, again, the assignment's not due till Monday night, so hopefully you can come to me Friday or Monday, or if you don't get it done by till Tuesday next week. If you have to come see me Tuesday, come see me. I know this is kind of the biggest new work that we've done so far. Hopefully it goes well, and I'll talk to you guys soon, all right? Okay. Perfect. Have a great day, guys.